Alright, so we're looking at I took the screws out of the front because I wanted to take the bottom plate off. I think this is a Palomar, although it doesn't say anymore. I think it's a Palomar of some sort. A 1 driving 4. 1446 driving 4 of the 1446s. So 1x4 basically here. Interesting that that's just kind of floating there, but I guess it's okay. So I'm not much of an amp person, but I do remember running quite a bit of this Palomar stuff back in my younger CB days. So these were really popular back in the 90s for me. And as long as you didn't overdrive them and stuff, I think that they used to work pretty good, you know. But the problem was people get carried away and stuff, and people were using some really poor quality meters back then and stuff like that. So I'm sure maybe at one time this, when it was new, might have came with some literature, and maybe it told you, you know, like what you should put into it and how much and all that stuff. So I'm going to try to be conservative with it and not overdrive it. So I'm probably going to grab one of those Aries 2 that I have, or yeah, I think I got one that's already kind of set up, and run that into it because I know I can control the RF power peak even on AM with it and stuff. So I just want to be careful. So you figure, you know, if we got 1446, I don't think any more than 10 to 20 watts is really all it needs probably, and it's going to do pretty much what it should. So I'm going to get it hooked up. Now this does have 2 separate power lines, so you know, obviously, like a lot of these, they're cut kind of short. So, but I can hook it up and demonstrate it and stuff. He wants me to try to sell it for him, so I'm going to do that for him. Good friend of mine. So first I want to test it and see how it works. I've never hooked it up before, so I have no clue. But it looks pretty clean on the inside. Like, it doesn't look like it's had a rough life or anything. So maybe somebody took good care of it, because it sure does appear. I mean, like I say, I'm not an amp person, so I can't tell you the ins and outs of it. I just know that it's obviously going to have an input requirement, and don't drive the piss out of it, because at a certain point you're only going to get what you're going to get, and at the end of the day you're just going to ruin it if you try to get too much out of it. Looks like somebody dated it August 3rd, 98. 600 plus something. I don't know what that means. I hope they ain't trying to say they were getting 600 watts out of this. Alright, so we got her hooked up. What I would probably do with this, and I'm not going to do it personally. If like I have interest in this, maybe I'll work something out with him directly. I don't really know. Don't really think I will, but you never know. It may spark my interest, and if it does, then this is just a demo video basically. But the power wires here, probably remove that little plastic thing that kind of keeps them from wiggling around outside the case. You can probably pop that off that hole. I think this amp would work better with some AWG8 on the ground and the 2 hot leads. You could probably do that, and then you could fuse it, you know, internally. I'm not sure how many amps this is gonna pull. I do have a clamp meter somewhere, but I'm not gonna go through the trouble right now finding it. So maybe if I really find interest in it, I may do it, because I could just plug it onto this cable, I think, and see what it's drawing. But I'm going to assume that this probably is going to draw like between 20 and it's just a rough estimate, but especially on SSB, this is supposed to be automatic sideband. Most of these Palomars were. Well, let's see if we can power this guy on. Oops, I unplugged my power supply. Yeah, a lot of times underneath they would say automatic sideband or something. Apparently the preamp works on this too. So I guess we'll start off in low and kind of see what happens. But first we'll see what our radio is doing. I don't know if this one, if I've aligned this one or not. And this is my old one. You can see it looks different. It's got the original face on it, but it has the newer firmware, or at least it was new back then. So just want to take it easy on this and just kind of start off and see where we're at first before I do anything to it. Of course we're on the dummy load, so whatever we see here is just whatever it is. We're not transmitting on the air or anything like that. So carrier, let's see. Let's just start it really low just to be safe. Why am I on channel 3? Oh, that's because it, yeah, okay, never mind. I always shut that off on my radios. I'm not a fan of this. On a lot of these radios, when you go to RF power and then you can see a value, because I just look at the power meter, so I would shut that off, and I always usually do, but this one I guess I must have done the full reset on it in the menu or something, so we'll just set it for like a watt and see what happens. Let me do this and do this, and now we're set up. So I'm just curious to kind of see. This should only do like 1, 2, 3, 1, 2, 3, 4, 5. Check, check. Yeah, it's gonna do really low power, but I don't know what this amp, so we're just gonna switch the amp on and kind of see what's gonna happen here. So you can see that relay kicked on. It jumped it up to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check, check. 1, 2, 3, 4, 5, 6, 7. So, I mean, it ain't doing that much, but, it still looks rather clean on the spectrum analyzer. So, you can probably go a little heavier than a watt. So, let's see. Since one gave us 8. Let's try about 3. 26. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's about, I don't know, between 60 and 100, somewhere in there. So I guess we're not overdrive. That's on low, by the way. This is medium. So on medium, we're up to 75, swinging about 200 and something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On high, 124, swinging about 357. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, radio. Let me back down the carrier some. That's probably better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously you can really take it easy on it. And this amp would probably be a lot happier running it like this, to be honest, instead of running it at the 300 plus mark. But it's getting kind of warm, like it should. So, but let's just find kind of a happy balance here. I'm going to probably put this back up about 90 on the carrier with it keyed. So about 90 on the carrier when it's keyed, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello radio, check 1, 2, check 1, 2, 3, 4, check, check. So anywhere from 200 to 300, give or take. And the good thing about it is we're not showing like a severe like splatter into the adjacent frequencies or anything like that. So that's pretty nice. But let's see about going some span out. Let's go out to, I don't know, we'll go kind of far out. We'll go to 100 megahertz. And I'm probably going to have to adjust my resolution bandwidth here, yeah, because it's going to be way out of whack. So we'll just go auto, auto. Oh yeah, so definitely has some, like all the CB style amps, there's a ton of spurious emissions here. Hello radio, check, check, check. Hello, and that's where a lot of that power is coming from. Hello radio, look at all that. So yeah, that's why I'm not a fan of the CB style amps that much, because of things like that. And the low pass filter ain't gonna do squat for the stuff behind. So let's go and see. It's just like all the RMs and stuff. They have that wicked one here. I'll be right back. I want to try to line up a few settings here. So some of the spurious stuff was kind of low, and I did bump up the reference level a little bit, which did obviously remove some of that stuff off the screen. Now when I modulate this, some of that stuff is there, and I mean, that is kind of crazy. Hello radio, I don't know what the heck that one is there. Let me go to peak table. Hello radio, 1 2 3 1 2 3 1 2 3. Hello. It's kind of crazy, but I wish I could. There's got to be a way to do a peak hold on this, because it's rather, there's one or two there that keep popping up. That number 2. Hello, check, check, check. 1 2. It's around 20 meters, and it is freaking strong. It's very strong. So just know that if you run this, there's a good possibility that you're going to be interfering with the amateur bands. And I would definitely recommend getting yourself a bandpass filter for this, as well as a low pass filter. You're going to need both. There's no way around it. So, but let's see what it does on single sideband. I feel like it's going to rip it up on sideband. A lot of power, but also probably a lot of spurious. So let's go to sideband. First, let's test and see what I was putting in on AM, because I'm just curious. 2 watts. Hello, check 1 2, check 1 2 3, check 1 2, check 1 2 3. About 9 to 10 on peak. So what you're seeing here, anytime that you transmit through an amplifier, it still affects what your radio does, because the RF comes out of the radio, goes through the amp even when it's disengaged, and these kind of CB amps have no filtering at all, so there's still byproducts that are still generated internally through this mechanism as the RF passes around and goes out. That's why we're seeing this big one here, which is, even though this is a lower power measurement, only a couple watts. That's our second right there, but that one is pretty bad, and a lot of these CB style amps always have a really nasty one at 81 megahertz or so. The RM Italy's do, and then it just bumps up. So the second is okay, it's not that high. We're talking maybe what, 8 dBm or something. I mean, because our fundamental's at 50, so about 50, so it's about 42 down. That's not too bad. That's normal, I guess, but the next peak, that's about half of our fundamental there, which isn't very good. The low pass filter would take that out. Let me span out a little bit more. 200. This is still on AM, so yeah, that's when you start to see some other things come into the picture. Now, I don't know if this sampler I'm using is going to be the most accurate anyways, so some of this stuff may not necessarily be as bad as what it is, because I'm using there's a sampler on the LP100A, so I'm not sure how high in frequency that goes. I want to say it goes to at least 6 meters, so maybe some of this stuff could be self-generated because it's kind of out of spec. Now, I do have a bird I'm sorry, a coaxial dynamic that's good up until the gigahertz of sampler. So that might be something that would be better suited to do this test. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, radio. That doesn't mean that that stuff around 20 meters isn't. That's accurate because this is well within the HF spectrum. What that sampler up there is going to show. So pretty crazy. Let's go back. Let's just go to center frequency of the one that we're on, and then span out to, let's say, 60 megahertz max. So start at 0 hertz and end at 60 megahertz, and this will give us a better understanding of what we're seeing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's almost like some of that spurious stuff is just it's there and then it's not, which is really weird. Hello radio, but man, it's like so high on that fundamental frequency there. It's almost 35 dBm up at times. That was even higher. So I don't know why that's doing that. I haven't seen an amp do that. This is on high. Let's see if I go to medium, if it makes any difference. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's still there a little bit on medium. 1, 2, 3, 1, 2, 3. Hello radio. Kind of pops up once in a while. What about low? Hello radio. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, this would definitely be the better way to run this amp. It's much cleaner here. I'm not seeing any of that spurious crap popping up there. So 1, 2, 3, 1, 2, 3. And let's see if we go here and bring this down a little bit more. And bring this down a little bit more. Yeah, that's looking pretty good. So peak, left peak, right, whoops, next peak. About 44 dBm. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty good. I think this amp is, excuse me, the cleanest on the low power. So I know most won't like that because hello radio, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it's not very attractive on the power meter at the low output of the amp, but it's very clean, and if you like cleaner RF, then this is the better way to run it. So, and if you don't have any equipment like this, you'd never know. Let's see if we can't bump up the carrier a little bit on this. Not going too crazy. What is that, about 3.3 watts in? That should be good. Hello radio, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check. Hello, 1, 2, 1, 2. And again, this radio ain't gonna drive the snot out of this thing either. So hello radio, there's about 150. So you might say, well, man, I got a 2-pill or something that does 400 watts. I'm like, yeah, good luck on that. That's all I can say to that. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, we're only hitting it with like 3 watts, maybe swinging 12 to 15. There's a high mark of 20, but obviously that's not very consistent. So I would say that low on this is the best way to run it, but I know guys would get it and run it on high just because they want to see that power. So let's put this on sideband. Hello radio, 1, 2, 3. I'll just turn this up just a little bit more. I'm going to try to put in like maybe 15 watts into it. Hello radio, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's probably good there to start. So we'll leave it in the low power setting. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, there's a little bit of spurious popping up down there around, I think that's around 20 meter. But it's well below, well, you know, our fundamental is going to be up there in that 40 plus dBm range, and then our That little bit there is in the negative range. It's probably like between that one line there is -3 and the other one's -13, so it's probably like -6 or something. So we're quite a bit down there. I wouldn't be too concerned with that. But now when I put this in medium, it's probably going to start to come alive a little bit. So hopefully we can see the power meter here for those that want to see that too. This is medium, and then you start to see some more of them spurious emissions start to come out, and obviously the amp really kicks up on power, but also is when you get some of that spurious stuff. And you can notice when the spurious stuff is there, that's when the power really comes up on this thing too. So you know, a lot of your CB amps and stuff, you know, there's always going to be those spurious emissions, and somebody might show you a spectrum analyzer, but a lot of times they're going to show it like this, let's say out to 500 megahertz or something, and 1 2 3 well, I guess it would help if we had our center frequency right. Span out to 500 megahertz. 1 2 3, and I mean, wow, look at that. But again, if you have your amplitude all messed up and you don't have the right reference offset, then you're never going to see really what you need to see. And again, I don't really, with my own testing, I already know, because I'm using this LP100A sampler, anything above 60 megahertz isn't really going to be accurate for this test. But anything below 60 is ideally going to be accurate, because that sampler up here, and this is what I'm talking about for anyone that doesn't know, this box here is the directional coupler for the LP100A. The RF comes in and goes straight through to the dummy load. This is a sample port. I think it's 50 dB down, and that goes directly into the front of the spectrum analyzer. This thing is getting really hot, so I'm not going to drive it any harder than this because I don't want to break it. So obviously we'll do it really quick and high just to see, because I'm really curious. But 1 2 3 1 2 3, check check check, hello 1 2, there's 430. I knew it would get down, but let's go back and look at it again on the 60 megahertz span, because I'm curious. 1 2 3 4 5 6 7 8 9 10, check check check, hello. Some of that stuff's popping up around the 0 dBm. I mean, it's still about 40 to 50 down, but it really, a lot of that stuff shouldn't be there to begin with. Even if it's still 40 or 50 dB down, that's still, I mean, there's still some stuff there, and maybe I'm just too picky about stuff, and that very well might be the case. So let me, since we're doing this, let me grab my other, my bird meter, and I'll put that coaxial dynamic element in there, because I'm really curious to see what this actually looks like accurately going out higher in frequency. Alright, so my bird meter, I forgot I have to get a new SO239 for the side of it, so I had to use my coaxial dynamic, but I actually like this one a little bit better anyways. So what we got going on now is the output of the amp is here, so it's going through the line section, and then it's going into the same bird dummy load up on top of the shelf there, so nothing's changed there. The LP will still show power, but now we're going through this coaxial dynamic meter, and I have a sampler element here, where the heck is it, right here, and this is good up until, let me see if we can pop it out. $87005. Let me look that up. I think I got the little case for it, actually. Hang on. Now this is what it is right here. So it's good up to a gig, 2 megahertz to a gigahertz. So that's perfect for what we want to see. This is going to give us a better understanding of when we go farther out in frequency, what's actually happening. Because I know for a fact that LP100 sampler just isn't going to do it. Alright, so remember, we're only hitting this with about 13 watts, so it's not a lot of power going in. Okay, I'm going to switch this on the high side. It looks like I got a freaking cluster, you know what, going on here, but everything's hooked up right, so I'm just using this duster because it's got just enough clearance to where when this is hooked up by this double male, it's not one is higher than the other and it's flopping around. So everything is good. We got some wires and stuff, but it's all good. It's just I'm not set up to ever run like this, and but I don't mind just making kind of a mess of my workspace here just to do these kind of tests because I think I find it interesting. Whether others do or not, I guess we'll wait and see. But I really enjoy doing this stuff, so that's why I do it. And it's not that I'm knocking the amp, I'm just trying to bring awareness to what actually goes on. So we're spanned out to 500 megahertz, which is over here. And each one of these spaces is 50 megahertz. So we look at 50 megahertz from here to here and here to here and so on and so forth. So middle frequency center is 250 megahertz. And this is sideband on the high power side. LP100 still hooked up. This actually has a 1000 watt element in it on the other side. You just won't see it. I didn't even flick it on or use the peak circuit or nothing. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check. 1, 2, 1, 2. So it's not as bad because now we're using a sampler that obviously has a more realistic expectation on farther frequency out. So let's see, 50, 100, 150, 200. I think about 250 span is all we need. So 1, 2, 3, 4, 5. Yeah, I'm not seeing much past about 200 megahertz. So I'll bring this back to the center frequency and then we'll span out to 200 megahertz. And that's going to give us a better idea of now of like how bad is it between now and 200 megahertz. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, that's not right. I messed that up. Let's go back to what I was trying to show. Span to back 200 megahertz span. So now center frequency is 100, 200, 0 hertz. Each one of these is what 20 megahertz, I think, because there's 10 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still pretty bad. I mean, there's quite a few of those are up there. Hello, that one is up there almost 25 dBm. So at about 100 and what is that? 160 megahertz, which is your no weather band. So yeah. CQ, 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 CQ. Hello, CQ, CQ. Hello. So yeah, right here, that's a really bad one there, about 160 some megahertz. That's going to interfere with your no weather band. And 25 dBm is pretty strong considering that if you figure CQ, 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 hello, about 200 watts is going to be present there at 162 megahertz. So that's quite a bit of loss there. You know, this amp is generating a lot of excess stuff, and that's why it's getting so hot. Also, because although it's producing power, there's a lot of other things going on in there that's spreading power out in places it shouldn't. And if it had a proper filter installed in it, it wouldn't do that. And also, we wouldn't see the 1, 2, 3, 1, 2, 3, 1, 2, 3. Hello, check, check. Hello, 1, 2, 1, 2. Let's span this back to a little tighter. We'll go 60 megahertz. 1, 2, 3. Hello. Whoops. That's actually fine right there. Right at the second. 1, 2, 3. Hello. Check, check, check. 1, 2, 1, 2, 1, 2. So I think actually this element might be a little bit better for overall testing because I'm not seeing as much of that spurious stuff either as I was before on the LP100. So if I plug this back in up there, let's see. Let's just do that really quick again. I'm just curious. Plug this in if I can get it back up there. I was using this with my pure signal, but I'm not using that radio too much these days, so I may actually reconfigure my testing apparatus and go back to using this up here. for testing, because this might be actually a little bit. Now we're going to get the sample from the LP100. So from the LP100, check 1 2, check 1 2, hello. I don't know, I kind of trust the LP100, what it's showing here, a little bit more, a little better, I think. Only because, well, the reference is set for that one. I'd have to set the reference on the spec an for the other element. So I think for the higher frequencies, this one is better, the coaxial dynamic. For anything below 60, I think the LP100 is better. So I have a combination of both. Because if we span back out to, what did I say, 200 megahertz, well, I'm sure it's going to be different now. 1 2 3, 1 2 3, hello. Not really, to be honest. It's just showing some more of that stuff in the lower frequency range. So hello, check 1 2, hello, check 1 2, 1 2 3, 1 2 3, hello. But yeah, they look about the same, to be honest. So maybe it is fairly accurate. Two different ways to look at it, I guess. We're taking the sample a little bit closer to the amplifier off of this versus up here, so it's traveling through some jumpers a little farther, but all in all, I'm pretty happy with both results. Let's plug this back in down here. Let's just have another look at it real quick. 1 2 3, hello, check check check, hello. Yeah, some of that stuff might be a little less, but then again, let me set my reference. I'm going to go to AM for that. That way I can look at a carrier. Just 1 second. Yeah, so on this one, I've just set my reference offset a little higher. 50.5 dBm here. About the same there, so that's fairly close to where I need to be. So now let's check the amp. Now again, we're using this sampler down here, and that's important when you're taking measurements to have the reference right when you're doing this stuff. So let's see here, let me switch this amp off because I just want to make sure I'm putting in the, I don't want to hit this any harder because man, it doesn't need it, you know. That's why I think guys were burning these up probably back in the 90s and stuff, because they were using crappy power meters and everything was turned wide open all the way, and you know, you're just killing those transistors and blowing the keying transistors and blowing up everything in the amp. It's just poof, you know. So you got to be really careful with these, and they don't need a lot of drive. That's probably plenty right there again. Well, hello radio. Okay, so let's turn this back on. It's on the high power. I'm gonna span that back out to, whoops, not 500, 250 megahertz, and our center frequencies here 125. Whoops. Let's actually just go 200 megahertz instead. 27205. Alright, same situation, 100 megahertz in the middle, 20 megahertz each gradical. 1 2 3. Whoop, how come we're not getting the measurement here? Did I not plug that in? Start that over. Something got latched up for a minute. That's why, because I reset it. Okay, there we go. And then I have to do my reference again. It was 54.5 or so, I think. Let me go back to AM and just double check that. I want to make sure it's right before I do it. Okay, so we're in that 500 megahertz span right now. Reference offset is set, so we'll see the dBm here and up here, 52.6, 52.7, same there. So that's good. It means we're where we should be. I'll put it back in sideband. Put this back so we can see the power. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, check, check. That's about the same, really. So, again, either one I guess I can use. It's much easier to use the LP. Just because I don't have to bring extra pieces over and use extra wires and do stupid stuff like using that. So, alright, let's check it for that lower frequency one again. So this is, we were looking for something below the fundamental, which it is there. It is there here also. So 1, 2, 3, 4, 5. Check, check, check. Hello. It is there. So I'm pretty confident that that one is good. Up to, I'd say, about 200 megahertz or so. I think it's okay. I know this one is probably a preferred one to use, but you know, with that being said, I think either way you can't go wrong as long as you have the reference adjusted right. And obviously I could change a little bit more of the attenuation in the reference level, which just adjusts up here. But what I'm seeing here is there's still some spurious emissions, you know, at least about 5 dBm down, negative 5 dBm. And obviously, you know, we're in the high 40s, if not close to 50 on the fundamental. So it's still quite a bit down. So this is, you know, this amp isn't, I guess it's not horrible, but what we need to realize here is you are going to bother maybe some stuff a little bit. Going out in frequency ahead, you definitely need a low pass filter for this. I mean, that 160 megahertz area is horrible. Well, let's kind of focus in on that really quick. We'll just go 160 megahertz center frequency and span of like, I don't know, 10 megahertz. Just to kind of see. Hello, check, check. Yeah, there it is there. Let me just go to AM and throw a carrier, and then we'll see that a little bit better. 163. Let me kill the modulation. 163, 226. All right. 163.226. 25 dBm. That's pretty bad. So my local no weather is 162.475. So that's really close. You put a low pass filter after this amp, that'll go down significantly. Probably would go away pretty much all of it. Even which we would burn this band pass, but even this band pass would help. But again, that's only for 200 watts, so that would be smoked. That wouldn't work. You'd need a low pass that can handle the power. Again, I don't think you should run this on high. And even my friend said that too. I think he found that there's quite a bit of reflection. I'm not sure about that, but I can check that. I can check that by putting a different watt meter element in this side, and you know, but it's going to be difficult because you guys aren't going to be able to see. So I think he said there is a little bit of and it depends on the radio too. Certain radios are affected a little bit different. I'm not seeing any major reflection here because if there was, this radio would trip SWR protect. So that's the beauty of these radios. When there's something not right, it tells you. So I'm not seeing anything really nasty. This is low power right here on sideband. 1, 2, 3, 4, 5. Check, check. Oh, that's actually AM. Sorry. 1, 2, 3, 4, 5. Oh, I got the mic gain off. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check. Even on low power, this thing's doing quite a bit of power at that 162 mark. So medium power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check, check. 1, 2, 1, 2. Hello. Probably medium power would be better to run on this than high, but you know, all the way up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 417 with 12, 13 watts of drive. So I don't know what you guys think about it. I'll put a low pass filter on it really quick, and we'll see what it does. All right, just so that we're all in agreement here, I'm back on the LP, about 50.1 dBm. about the same there. So I'm back on the LP sampler. So I do have this massive low pass filter hooked up. This is good for 6 kW PEP, and it starts to attenuate. Actually, I found, and if you're interested to see how filters work and stuff, I did do a video on my ham radio channel, which is just my call sign. You can look that up. I showed this one. I showed another Drake low pass filter. I showed this band pass filter, which is pretty cool, that you could use to do certain things. You could use it with a low pass filter and it would work really good, and that would help block out some of that stuff that is happening behind your TX passband, you know, the stuff in HF going lower that a low pass won't help you with. So you could use a combination of both. Obviously this wouldn't work for this situation because it's doing too much power. But if you had a higher powered one, you could put the band pass on the output of the amp first and then the low pass. And then essentially, and I show that in the video, kind of what happens is it literally, you see the band pass, you know, I'm using the tracking generator with that, you see the band pass, and you literally just see like a value, just boom, like nothing, because the low pass also affects what we're seeing. So I thought it was cool. I like to test and do stuff like that. You know, you just don't buy this stuff and just have it sit here and not do anything with it. It's fun to experiment with these things and stuff. They're full of information when you tell, but you have to tell it what you want it to show you. It doesn't just do it for you. So it's a little user intuitive. But anyways, let's see where we're at now. So let me adjust these back to auto, because when I span out it's not going to be clear. So we'll just go out to 200 megahertz again and we'll see what happens. Let me put this back on. Alright. First I gotta adjust my drive again because I was playing with the carrier. So hang on a second. 1, 2, 3. I'm gonna turn that up. 1, 2, 3, 4, 5, 6. We need about 12 or 13 watts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check. So this would be kind of like a normal, like old school, like CB radio kind of power on sideband if it wasn't all cranked up. That's good there. So again, the amp's on high. It's on. Does the preamp work on this really quick before we? Does it? Yeah. Yeah, it works. So it does have a preamp that works. So okay, figured I'd show that. All right, let's see what happens with the low pass hooked up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, check, check. 1, 2, 1, 2, 1, 2. Hello, radio. So it's attenuating all that stuff above the fundamental. But man, what the heck are we seeing there? 1, 2, 3, 4, 5. Check, check, check. Hello. It's really bad. It's really bad again. 27, 205. Let's just go like 27. We want to go like 20 megahertz. It actually might be too. Let's go 30 megahertz. Yeah. So now we're looking at start of 12 megahertz, stop of 42. I want to see what's going on behind the fundamental. 1, 2, 3, 4, 5. Check, check. Hello, radio. 1, 2. That's about 25 dBm right there, whatever that is. Let me key up on AM and see if that spikes there. No, it's not there on AM. So I feel like it's I feel like the MOSFET, or I'm sorry, not the MOSFETs, but the transistors in this amp are oscillating, and that's why we're seeing that at times. They're in full oscillation. So this amp, although it's doing more power on high, I do not think it's designed the right way to really effectively run high power. So, because I think when it's oscillating, that's why we're seeing that fluctuation there. 1, 2, 3, 4, 5. Check, check, and it's kind of doing that on both sides. And I can kind of hear the RF kind of bouncing out of the pills, like you can hear the pills talking to you, and that's not usually a good sign that things are working right. You shouldn't really hear yourself through the pills. the transistors, whatever you want to call them. I mean, I know everybody loves to see power. Hello, radio. Hello. This would be awesome if it was clean and it was effectively doing with 12 watts in. I mean, almost 400 out is it's pretty good. But let's try medium. 1, 2, 3, 1, 2, 3. So yeah, medium is definitely the way to go on this. It's not doing that oscillation on medium. So if you're gonna run this, run it on medium. I'm not hearing that weird RF sound or anything, and it seems to be working a whole lot better, and we're still getting pretty good peak power out of it, you know. I mean, this is only with what is it? Switch that off. Hello radio, about 12 watts of drive, so 13 maybe. So yeah, it's definitely working good there. And hello radio. So yeah, don't run it on high on sideband. That's my testing find there. Is it's not going to work effectively. It's oscillating. It's too much. So you definitely want to run a low pass filter with it. I'm not selling this one. This one is like, I don't even know where I got it. But I feel like, and like I said before on a couple other videos, I talked about some amps for like the CB hobby and stuff. And yeah, guys, I never said guys don't build them with quality and stuff, but the problem is they're not putting any filters. And I feel like a band pass and a low pass wouldn't hurt. You know, obviously it's going to raise the cost of the amp, but if you start doing that and trying to explain to your customer base as like a builder, which I have no interest ever getting into making amplifiers or anything like that. I just have no interest. But I know they're very popular in the radio hobby, whether it's ham radio or CB radio or whatever have you. So I don't mind talking about it and stuff. But again, that's just from my experience here is you know, and having the ability to test this stuff here to see what I see. I wouldn't want to run this amp the way it sits right now unless I had this filter on the back of it, filtering that output. And also I wouldn't want to run it knowing what I know about what I would see on the high power setting. I'm not saying that the amp is junk or anything, because it's just, I'm not saying that. I'm just saying you don't know what you have until you properly test it. And that's something we normally don't see in the CB hobby. You might show a guy key up on a spectrum analyzer and he might have the span out to a gigahertz or 500 megahertz and his reference is way off and you're not seeing anything. You're only seeing what they want you to see. So, you know, and you could grab an HF amp and you could test it and you're going to see that they're not going to do that stuff, and they're not usually going to oscillate because they're not designed to do that. Like they really put quality in them because they're meeting like a standard per the FCC or, you know, the CE in Europe. I mean, usually amps are built to conformity so that, you know, they don't pass unnecessary spurious emissions onto other radio services and all that stuff. So some of that stuff is forgotten about when guys are building the CB style amps and stuff like that. And of course these were no different. So I can't change the fact that they're still really popular. It's just, you know, people don't know what really they're using until someone shows them on a test. So where were we here? Yeah, again, this is okay here. It's not doing that massive oscillation or anything. And you can see the automatic sideband's working. I'm sure if I can hear that relay click, you guys can hear it. Maybe for a second it did it, but it's very minimal. Now let's put it back in high and see if I turn the drive down, if it settles it down. But just leaving it there, I mean, it's oscillating. So we'll take this. Where is it? About 22. Put it to 11. Okay, so now we're doing about half power. And yeah, it's still doing it. So for whatever reason, the high power, it's like full on. So whatever the attenuating pad in there from low to medium, it shuts it off on high, and it's just not, it's not good on high. So definitely don't run this on high. And I think even on AM, it's not really desired to run it on high. Well, let's just find that out. really quick here. Alright, I don't think it's going to do it as much on AM. Just want to see what that's going to give me for a carrier. I think it's too much carrier anyways on high. This is 2 watts, so we'll probably swing about 8 going into it. Hello radio, yeah, 2 to 8. So that's okay. Let's see what it does. This is AM on the high side of the amp. It's not too bad, I guess. 114. Let's see what it does. Hello radio, 1 2 3. Yeah, it's showing that oscillation there too. 1 2 3, 1 2 3 4 5. Check check check. It's not doing it as bad, but I wouldn't think that medium would do it. So let's find out. Medium, a little less on the carrier, a little less PP also, but starting to lose my voice here. I've been talking so much. This is a long video. Hello radio, 1 2 3 4 5 6 7 8 9 10. Check check check. This is real clean here though. So this would be a respectable way to run it. Obviously the filter, let's go back out to 200 megahertz and see. Yeah, so no problems now. Let's put it on high and see. Back on high, a little bit of that oscillation down in the lower HF, so it definitely doesn't do it as bad on AM, although it is there. And it usually only does it on those higher power spikes. So I think this amp, we're going to wrap it up here in a second. I'm going to get it all unhooked, and I'll give my final thoughts on it. Alright, so we're going to wrap it up here. Spent a lot of time on this. Actually, that's one thing a lot of you guys might not know about me, is I love testing stuff and learning about stuff and just using my equipment to kind of like determine what are these things doing, other than we know it's going to make you get more power, but where does that power go and what happens when this creates power? Because we have no control over that. Once it's here and it goes out your cable to your antenna and it's out in the RF world, we don't know, but yet we should be responsible for it. And by not knowing it, it's not anybody's fault, because most guys are not going to sit there and spend the money to, you know, buy themselves some test equipment. And like I've always said before, I don't have the best of the best. There's way better equipment to buy, but for what we're doing and what I'm doing with amateur radio, or for CB radio for that matter, I think I got some pretty decent stuff, and the goal here is to continue to learn how to use the equipment, because like I said earlier in the video, this doesn't do you a lick of good having this signalant here. You could have a Rigel, you could have an older HP or something, a communications test set. I mean, you could have whatever you have. If you don't know how to use the equipment, and it goes into, you know, using a sampler and being able to, you know, measure the power and make sure that the reference is set properly and the level of attenuation so that you don't blow the front end of this off. There's a lot of things that go to it, and I couldn't teach somebody how to do that personally. It's things that you learn as you go, and it's like I'm not done learning. Every day I use this spectrum analyzer, and I sit here and I almost teach myself how to use it by just experimenting with it and stuff, and it's a lot of fun to me. And when I'm not doing a lot of things with the business, like setting up radios and stuff, when it's a little slower, I don't actually mind at times, because it gives me time to actually sit here and do a video like I just did today on the filters for the other channel that I have, and to do this video and hope that somebody gets enough out of this video to realize that what I'm going to get to in a second is, I don't think this is horrible. But with anything, there has to be, we have to come to an understanding that there's a certain way, I guess, that you should run it. And number one, we don't want to drive the piss out of this thing. And if we don't have a way to measure the power going in first properly, then we probably shouldn't be dumping any power into this at all. So it all starts with number one, having a right meter to actually measure the power, which, I mean, we do, but you don't have to spend the money on that. You can get other meters that are going to give you a good level of accuracy. The one that I showed a long time ago, the monitor sensors, is a really good option. I mean, even the DG103 Max that I sell is pretty good. Now, again, it's not going to be as good and consistent a peak as like an expensive meter like that, and you shouldn't expect it to be, but it's going to give you something that's better than nothing. The Ameritron AWM30B is a good peak reading meter. I mean, there's a lot of them out there, but just getting something at the gas station that might sell some CB stuff, you know, isn't usually enough to cut it. But a lot of guys do that because somebody made a good comment on one of my videos yesterday. They said they want to spend $300 on the radio, but then spend $20 on the antenna and coax, and that doesn't always work the best. So number one, we have to understand what we're putting in. We have to understand that it has a driver transistor, which if you fail that, if you burn that up, the whole amp is pretty much toast then. It needs to be repaired. Number two, we don't know exactly what the amp is going to do even when we put RF into it, because our meter kind of lies to us no matter what. When this thing was kind of self-oscillating, we saw the most power out of it ever. But we also saw a lot of spurious emission artifact on the spectrum analyzer that, you know, we wouldn't see without it. So that tells me that there's something not right, and we need to either lower the drive, which in this case is, you know, the attenuation pattern here from the high to the medium makes a big difference. And I feel like on this amp you shouldn't go any higher than medium. So that's my recommendation if anyone buys this. I will put a link to it. I will take some still photos of this on the website, and I'll post it. And it's going to be posted just for experimental and you know, whatever use. It's not really, I'm not posting it to be used on air. It's just for fun, like what I've done. If you want to buy this and just test it and have fun with it, whatever you do is up to you. But just know that, you know, I'm not endorsing using this on any of the bands or anything. That's up to the user that buys it. So I fully tested it and it's working in all facets. So that's all I can show you after the fact. If somebody buys this and it stops working, I'm not going to give you your money back. I've showed it working. I've made almost a whole hour of video here. So you buy it with confidence knowing that it's working. One thing I'll point out is you're probably, like I said in the beginning and much earlier, you're probably going to want to maybe rewire it. If you can't do it yourself, have somebody do it for you. Send it out. Because I noticed that on this fuse there's a hot wire, a little bit of exposure there. So you need to be really careful when you're using this, and don't let anything ground oriented touch that, or else it's going to short something out. And I'm just making somebody aware of it. If you're truly interested in buying this video will be on the website link. Watch this whole video. Spend your money wisely. If you watch the video and you still want to buy it, it's here. You buy it, I ship it on Monday if somebody buys it this weekend. I mean, there's no ifs, ands, or buts about it. It's going to go out the door. I'm not really interested in it. I thought possibly, but I don't know. I always say that stuff because these are kind of nostalgic for me, but at the end of the day, I don't really have interest in it. I'd rather just talk barefoot and just let conditions prevail where I'm going to go. So but that's me. It doesn't mean everybody's like that. So the preamp works. Again, either use low or medium. I wouldn't ever use high. We've already kind of proven that. And yeah, that's pretty much it. So you can see it. It's not in great shape, but it's fully functional. And you know, what do you expect for like a 30-year-old amp? I mean, yeah, you could wash it off. I'm not going to do that. Probably you might want to put a fan on the top of it or something, you know. But you need to be very aware of the drive that you put into this, because although it does a decent amount of power, it's still a low drive amp. So don't be putting no hopped up all the way, limiter ripped out, average power, mod, swing, whatever, AM, splatter, whatever radio into this. You will vaporize it very quick. and you put one of those radios that has sideband into it, that has all those mods like that, and the same thing, you're gonna vaporize this. It's gonna blow up on you. So just be aware. Don't say that I didn't warn you. If that's something that you're not fully sure what you're doing, then don't do it. I mean, it's as simple as that. So I wouldn't say I was overly rough on it, and I've proven that it doesn't take much drive. So with 12 watts PP, even on the medium, we're seeing what, 300 plus, which is really good. So you figure it's got 5 70-watt transistors, so, and that's running it at full, which we've already proven as well that running it at full isn't very good for this. So all right, hopefully you guys got some out of this. It was fun for me, but you know, I'm trying to help out my local buddy, and if I can get him some money that he needs for it, that would be great. And appreciate everybody that supports the channel and watches the videos and comments and the whole 9 yards. 73. We'll catch everybody later.